Hi, good evening. I think we are ready to start. So welcome to WinDriver Introduction Webinar for Linux. My name is Daniel. I'm the Technical Customer Success Manager of WinDriver. Perhaps you've already corresponded before. This webinar is one of many other upcoming webinars. Some of them are introductions, and some of them have dedicated subjects. For example, next month we will host 2 webinars dedicated for troubleshooting, one for Windows and one for Linux. I highly recommend joining them. We will publish everything, the links for registration on our newsletter and on our LinkedIn page. If you want more details regarding it, or if you want me to personally send you the registration links, send me an email. This is my email, and I will make sure to personally invite you. I highly recommend joining it. On October, we will host a distribution webinar for both Linux and Windows. And in between, we will have other introduction webinars. So stay tuned on our LinkedIn page and on our newsletter. We know that there is a high demand for it, so we are also working on Kernel Plugins dedicated webinar and interrupt handling webinar. It's to be announced. We will make sure to inform you regarding them as well. They will be available, like all of our other webinars, on our YouTube page once they are done and recorded. So what are we going to learn today? We will have an overview of WinDriver. We are going to discover its mechanism and the kernel module, WinDriver kernel module, how it works, what its functions are. We will overview WinDriver top functionalities, like read-write to device, how to handle interrupt handling, DMA, CMake files, kernel plugins. If it doesn't say too much to you, that's okay. We will go through it during the presentation. We will overview WinDriver utilities, the WD debugger, the WD-Reg, the samples we offer, and the PCIe and USB diag. At last, I will present the licenses available for WinDriver and what they are used for. So simply put, WinDriver is an easy user mode driver development tool. It allows you to generate code in different languages, for example, C, .NET, Python, and Java, and access and write a program, an app, or a driver to your USB or PCIe device, regardless of its manufacturer. And we have enhanced support for specific chipsets from Altera, Xilinx, and Lattice. The examples, we will go over them later, but they have been tried on specific chipsets, but you can find inspiration for how to develop drivers to these kind of devices. All you have to do is to generate the code automatically from the wizard, modify it as per your device preferences and settings, build the code if you are programming in C, then you will be able to run and distribute it. So how does WinDriver work? Let's start from the top. We have the user mode and the kernel mode. On the user, all the development and debugging is made from the user mode, which is makes things much more simple and less dangerous. and prevents crashes and hangs. So you have your driver you're developing based on on WinDriver generated code. The driver contains functions from WinDriver API. On our documentation, you can find a list of the functions and how they should be implemented. The API connects and communicates with the kernel module in the kernel mode via the WinDriver kernel module. This is why it is important to make sure that the WinDriver kernel module or your driver kernel module is properly installed on your Linux system. And the WinDriver kernel module from the kernel mode sends messages and commands to your hardware. The WinDriver kernel module can work with multiple devices and multiple programs. For example, if you have an Altera device and a Cypress device and Xilinx device, you can WinDriver kernel module can run multiple programs and communicate with multiple programs. Devices. But make sure you are not running more than one program with one specific device, so you won't get resource overlap. But this is possible as well. So we saw how WinDriver works in general, and now we'll see how easy it is to work with it. So Linux is not the most graphic operating system, so I'm sorry for all the black lines with the text. I know it's not too friendly, but this is meant to simplify the installation process and development process. All you need to do in order to install WinDriver is to install the dependencies, WinDriver itself, and then you will be able to run the driver. Make sure that the kernel module, WinDriver kernel module, was loaded, and then you will be able to generate your code. It's as simple as that. The full instructions are on chapter 3 on our documentation. But basically, these are the simple steps in order to run WinDriver. This line, the sudo wdirect WinDriver 1610, loads the kernel module. We will discuss the wdirect tool pretty soon. So after we have generated our code and we want to build our app, what should we do? So now we have folders and files on our generated project in WinDriver folder. So we have the project installation. If you named your project XYZ, you will have XYZ installation folder that will include an include folder that contains the header files, the lib that includes the WD API for this particular version, and the redist file, which contains the installation files for the user app and utilities, your user app, your project, distribution files. Another folder you may see there is Linux, which contains the make file for making your project on the host device, and a main folder, which contains the C and header files and the CMake list .txt. We highly recommend, not only recommend, highly recommend working with CMake list. There is an option to work with the make file, but it will be less convenient for you as well. So what we recommend is going to the main folder, which is the project installation, and run these commands, the CMake dash capital B build or if you want the installation files to be built into another folder, create the folder build and write CMake 2 dots after moving to the build folder, and then the CMake list will build your app into the build folder, and you will have everything in order and not mixed up with other WinDriver files, generated files. The file you will see in the folder contains the lib.h header, which is a library for controlling your hardware through WinDriver. The lib.c file, which is a very important file. This is where we update the driver name and distribution license. It contains the implementation of the function used for accessing each of the resources defined in the wizard. And the diag.c file, which is the sample user mode application that diagnoses your hardware using the project, this one, library. So we recommended when building using the CMake option. We will elaborate on it later under the utils, under the WinDriver function section. But I do want to emphasize or recommend using VS Code as well. Instead of building on the command line, which can, we all know, be difficult to track and to debug, we recommend working with VS Code. VS Code has a special CMake view of your build files, where, as you can see here, includes all the steps of the CMake list. You can install it on your Linux machine and run a GUI that will help you to compile the code with much more comfort. This is the link. And as you can see, you can also execute the task, and you will see that the build was finished successfully or not successfully. But it will be much easier for you to work with the GUI this way. Another thing which makes the whole development process easier with WinDriver is the option to redistribute your WinDriver-based package as a self-extracting execution file. What does that mean? So when you distribute your driver, you need to install dependencies, and you need to have preparations on your machine. You can create a self-extracting execution file that will take care of it by itself. It will install all the dependencies required and make everything in line in order for WinDriver installation, or your driver, sorry, installation to work smoothly with as less intervention needed from your customer or your app's user, your driver user. So you can look for the instructions on our support center. And this is another tool or another methodology that can make the whole building, compiling, and redistributing much easier for you. So now we will go over WinDriver top functionalities, the read-write to device, the interrupt handling, DMA, CMake, and kernel plugins. So maybe the most basic function expected from a driver, except for recognizing and opening the device, is the read or write to device. We have several ways of doing that. The first one is the GUI one with WinDriver driver wizard, where after you open the project, you can see the memory bars and then the memory range, and you will be able to read and write to the memory. add access registers and import registers. This is one way to manage your driver operation using the GUI, WinDriver Driver Wizard GUI. Another step on the way where you can define the read and write function is on the code itself, the generated code. You can see WDC write, WDC read, or read write. These are high-level functions from the user mode. You can find the elaborate description of them on our documentation, and you can set the reading, the writing, or both in the code itself. This one is taken from the WDC lib.h file. So you can build a file before compiling the code or during the building of the code, and also after. You can read write from device, in this case pipes, from the user app. Here you see I called this driver Joy because it ran a joystick. Joy diag, the execution file, and I have the option to read and write from pipes. It's a USB, and I can read and write from them via the user app after compiling the code, which is easy. Makes things a lot easier. Interrupt handling. So another, let's say, one of the more common usage of WinDriver is the interrupt handling feature, where you can basically create an interrupt handler and manage the interrupt calls from. So here again, you have three different options to handle your interrupts. The first one is from the driver wizard with the GUI. You simply click on interrupts, and you can add transfer commands, listen to interrupts, and remove transfer commands, all with a nice and friendly GUI. The second option is the WDC int enable function, which is pretty commonly utilized. The int enable function, not as suggested by its name, is not actually enabling the interrupts, but it starts the listening to them. If you want to utilize or use this function, I highly recommend reading the chapter 10, reading the documentation of WDC int enable to see how it works with the different type of interrupts and the required functions and variables it requires. If you want to learn more about interrupt handling in general, I recommend reading chapter 10, where there is a detailed description of what interrupt handlers are and how to create effective ones. And here we have the third option for handling interrupts, which is via, again, the user app. As you can see, I got interrupt number 1, and it's an MSI interrupt, message signal interrupt, and I can see the message data. So DMA, of course, the direct memory access, can be quite a challenging project to execute, but WinDriver can make it a whole lot easier if you want to know how. So this is it. First of all, we have the sorry if you're not familiar with DMA. So DMA is the capability provided by some computer bus architectures, allowing data to be sent directly from an attached device to the memory of the host, freeing the CPU from involvement with the data transfer and thus improving the host performance. If you want to perform a DMA and let's say not keep the CPU busy with the transfer, you have the sample, the XDMA GUI sample on our samples folder. You can see it is highly elaborated and documented. You can see the different steps and functions that are used and utilized in this sample. Sorry, this is supposed to be, this is the XDMA diag, and this is the GUI, which I will talk about soon. Sorry, the XDMA diag on our samples folder, where you can see a working sample for how to perform a DMA. Of course, it is working on the particular device that it was written to. It is not working on every device. So you have everything here. And also you can find more detailed description of the functions on our documentation and so on our support center. We also have an XDMA GUI program for a specific Xilinx chipset. As you can see, you can open a device and perform a DMA transfer. It will not work on other devices, but this is just yet another tool where perhaps you can utilize for performing DMAs. And of course, the third option is via the user app. For devices that include the DMA option, you will have the option to select the DMA completion method, okay, and interrupts pulling from device to device. Here we transferred only zeros, but you can actually see the transfer itself on the user app. So a complicated task, DMA, can be made much easier with WinDriver. So we talked about CMake file. If you're not familiar with the concept of CMake file, it's a CMake file generates platform-specific build files for Windows, Linux, and Mac OS, ensuring that your software can be built and deployed on different platforms with minimal effort. Basically, it's a text file that contains the settings that are required for each operating system you wish to install on. So instead of creating different packages for specific OSs, you can create a CMake file generated automatically, yes, with WinDriver for Linux or an SIS installer for Windows, and simply run it. And all the modifications that are required for this specific operating system will be handled automatically without your need in defining each one of it. And in general, we recommend working with CMake on Linux, regardless of other operating system distributions, because it's again much easier to build, to manage. And if you're using VS Code, as I showed earlier, you will also have a detailed preview, visual preview of your CMake settings. Another feature WinDriver offers is a kernel plugin. If you're not familiar with this concept, so kernel plugin is a critical section of the driver code to be moved to the kernel while keeping most of the code intact. What does that mean? So as I said, WinDriver is operating on the user mode and kernel mode. Commands and functions that are called from the user mode takes both processing power and time in order to be executed on the kernel mode. Kernel plugin enables you to take chunks of the code that are still intact to your driver and move them to the kernel mode. And it enhances performance because it takes less time, computing time, in order to be executed, and there are no additional kernel debugging. There is no additional kernel debugging because everything happens on the user mode, so it's much easier. So if you want to explore more about kernel plugins, as I said, we will have a dedicated webinar. There is no date yet, but you can read more about it on chapter 12 on our documentation. And we are publishing new materials all the time, and perhaps kernel plugin will be one of them, one of the subjects we will publish learning materials about soon. So these were the WinDriver's top functionalities. Now let's see a few utilities provided with WinDriver in order to make the development process much easier. So if you already worked with WinDriver, perhaps you are familiar with the WD debug tool. The WD debug tool is the, don't want to say official, but it comes with WinDriver and it debugs all WinDriver or your WinDriver generated app kernel operation. So as you can see here, and this was added in the recent WinDriver version for 16.1.0, you can see errors in red and you can see successful operations in green. You can see the functions that are called and they're clickable. That will take you to the documentation where you can see the description for what are they used for. And if you see an error, perhaps you will find the answer there on our documentation. You can track different sections and levels. We recommend trace and send a debug message to the operating system kernel debugger. And you can also track or monitor your driver. So if you generated a project, you called it 3-to-1 ABC, so change after you load the kernel module, of course, because it tracks the kernel operation to 3-to-1 ABC, and it will track your app, and it will help you to debug it. You can see if the function is not going well, if there's a license issue, etc. But this is a great tool. If you ever reached us for support, maybe this is the first thing we ask clients, to send us the debugger log so we can see what's going on backstage and spot the issues. We have the WD-Direct tool. On Windows, we have also a GUI version, but here we do not have a GUI version. Basically, the WD-Direct is allows you to dynamically load your and unload your driver, replace the slower manual process. Sorry, this should go away. We're not working with Windows Device Manager, but we do, let's say, work with LS mode. So the WD-Direct tool allows you to load and unload your driver module. In this case, I have loaded WinDriver latest version kernel module. So if you're getting an error that the kernel module is not loaded, or the device is not recognized, or anything like that, this is yet another way to load kernel modules using WinDriver utility. You can read more about it on chapter 16 on our documentation. Another great tool, which I personally use a lot, is the PCIe/USB diag. What it is generally a complete interrupt handler source code that uses the WDC interrupt functions, the high-level functions. What I like about it is that it is working. It's a working sample for scanning and accessing devices, which means that if I have an issue with a device, let's say I've generated an app, I run a project, and it's not working for me, I can utilize the PCI diag or USB diag execution files, in order to see if it is being recognized or if I can access it. If I can access it using the PCI diag, for example, the issue is on my app because it is working on a PCI diag. If it's not working for PCI diag as well, that means that something is wrong with the card, the computer, the BIOS, or something else. But the fact that it is a working sample makes it a great debugging tool. In addition, for accessing and opening devices, we also have a kernel plugin samples. Okay, so let's talk about our samples folder. This is a screenshot from Windows, but we have everything on Linux as well. We offer samples in different languages, as you can see, C, C#.NET, Java, PowerShell, Python. Each folder contains several samples. Here we have a sample for Altera, for Xilinx, for Lattice. We have the WD debug sample, the PCI diag, the USB diag. Where is it? Here it is, the PCI scan. You can enter, you can see the source code there, get inspired, maybe troubleshoot these samples to help you understand better how things work. But it is a very useful source for learning, for both learning and troubleshooting your devices. As I said, the PCI diag and the USB diag are complete interrupt handler source. So if you want to create an interrupt handler, these are great samples to get inspired from. Let's talk about licenses. So when a regular user signs up to WinDriver, or a client usually gets two licenses, one development and one distribution. The development license is bound to a specific computer with its registration code, and it is used to activate the wizard. It is not meant to be distributed. It is not working with other apps, okay? And it has an expiry date. Regularly 1 year after the purchase date. The distribution wizard does not have an expiry date. Since you are distributing your product, we don't want it to stop functioning. So it does not have an expiry date, but you cannot develop with it. It will not activate the wizard, and it will not work on the wizard. It can work with other apps, since it's a distribution license. We want it to maybe correspond with other applications you developed with your device. The third license type is an SDK, and it is obtained for software companies implementing WinDriver's API in their product, destined to be sold to their clients. Again, I believe we all know what SDK is, but this is an important distinction between the licenses type, and we know it may be confusing. We are working on a new mechanism to make this process much simpler. So we have other services, for example, special APIs. IPC is an inter-process communication API. It enables processes to communicate with each other and exchange data, regardless of whether they are running on the same computer. Okay, in this API allows the processes to share and interrupt, and even if they are not running on the same computer, okay, the same host, they can still communicate. This is a special API we offer. We have the shared kernel plugin, the shared kernel buffer API for allocating a shared buffer for different processes. SRIOV, a single root I/O virtualization. It is supported on Linux only. It's an extended PCIe capability, which makes one physical device appear as multiple virtual devices. The shared buffer API allows multiple device drivers to share a single DMA buffer in a system. And the server API, which allows scanning more than 100 devices. From the current version of WinDriver, we started to enforce the limitation for scanning up to 100 devices. If you have a server and you want to scan more than 100 devices, then you would need to acquire the server's API. For more details about these special APIs, feel free to contact me or our sales team to provide more details. The digital signatures is less relevant for Linux, but if you are also developing drivers for Windows, you probably know that your driver needs to be digitally signed in order for Windows to allow its installation. One-on-ones and TBR, this is something that I am doing. TBR is Technical Business Review, which is a meeting we have with our clients to get the feedback on WinDriver and hear more about their projects and goals and how WinDriver can support them. One-on-ones are short meetings for introducing WinDriver and onboard new clients. LinkedIn, our LinkedIn page is on fire, we can say. We have a lot of content there and relevant content as well. So I highly recommend looking for us, Junko WinDriver, on LinkedIn and follow us or like us to stay updated. As I said, we have more webinars planned in the future. Stay tuned on our website, on LinkedIn, on our newsletter. They will all be free, so you can join us and learn about WinDriver functionalities and more. That's it. If you have any questions, feel free to write them on chat. Or if you want to talk, send a message on chat and I will open your mic. So if there are no questions at all, thank you for joining us and have a great day or an evening, wherever you are.